everybody. Thanks for coming. I'm thrilled that the room isn't empty. It's such a great crowd. I'm Peter Burka. I'm a software developer at Two Sigma Investments. There have been a lot of talks this week about cool compiler technologies, data structures, algorithms, how we can make programs better. I want to talk about something a little bit different. I want to talk about how we develop and maintain software. So code review refers to some sort of process, however formal, of peer review for every change that's made to a code base. How many of you here do code review as part of your work process in your organization or group? Cool, that's great. I'm assuming the rest of you are probably students. Hopefully you will start doing code review, maybe even in your lab. Before we start, I work for a corporation and we have lawyers, and they would like you to read this legal disclaimer. So, what authority am I standing here today, or sitting here today talking to you? I worked at two different companies as they were growing. I started my career at a company in Ottawa called OTI, which was acquired by IBM. We built the J9 Java VM and the Eclipse IDE. Some of you may have used one or either of those products. And for the last 7 years, I've worked at Two Sigma Investments in New York as a software researcher. At both of these companies, when I started, code reviews were either optional or non-existent. We trusted small, close-knit teams of developers to reach out for consultation when it was necessary. We trusted them. It's a small group. Everyone knew everybody and everything. As we grew, both of these companies adopted more rigorous code review standards. I think this is a very natural part of growth at a company. It wasn't entirely painless, though. There were some conflicts and I think a lot of inefficiencies. And I've been looking back at those experiences, thinking about what we could have done better and how we could still improve the situation today. This is a practical talk. I'm a practitioner. It's based on my experiences and my opinions. Some of it is anecdotal. I'm going to try to include a little bit of science, though. There is some research on this, and when I can, I'm going to refer to those papers. In writing, there's a principle that says that groups of 3 things are more satisfying and memorable. So I picked out 3 points that I want you to take home today. I think these are essential for establishing a productive and healthy culture of code review at any organization. First, we need to identify why we're doing code reviews at all. This way, all the participants can have a common understanding of our goals and can all work together instead of in different directions. Secondly, we need to find ways of encouraging collaboration. Code review is fundamentally a collaborative experience. You can't do it by yourself. It's a microcosm of your organization's culture. Finally, we need to educate people to use code reviews effectively. This might seem really obvious, but I think it's surprisingly rarely done. Let's start with shared goals. What are shared goals and why do they matter? You've probably heard the anecdote that most drivers think they're above average. I live in New York City. I don't own a car. I rent a car maybe like 10 days a year. But on those 10 days, I look around and I'm definitely an above average driver. Is this because I'm overconfident, or is this the Lake Wobegon effect where all children are above average? That's part of it, but I think there's something more subtle going on. I think most people really are above average drivers. It's a poorly phrased problem, which is why. different drivers have different goals. I'm the kind of above average driver who follows the speed limit and anticipates red lights, so I slow down ahead of time. I think this really annoys the above average drivers behind me who are trying to get where they're going as fast as possible with only a reasonable number of tickets. So there's a conflict here because we don't have the same goals. I'm trying to maximize safety, they're trying to maximize speed. We're both doing better than average, but on different axes. I propose that most developers already are above average code reviewers, but they may have conflicting goals for code review. If we want to minimize fender benders and road rage in our code review process and maximize team efficiency, all the developers in our organization need to have common goals when they review code. Okay, so what are our goals? Yesterday in his keynote, Daniel Jackson said that every concept should have a purpose. Surely code reviews have some purpose. Obviously, our first goal is to find defects, right? Or maybe we do code reviews because you got an email from upper management that says you have to. It's the new company policy. I'm going to argue that these are not good goals. They might even be anti-goals. And they certainly shouldn't be our main motivation for code reviews. So, should we be using code reviews to find defects? Historically, bug hunting is definitely why we do code reviews. Michael Fagan from IBM is considered the father of code reviews. In 1976, he published this in-depth paper in the IBM Systems Journal, which is still worth reading today, talking about how his team did systematic code inspections. It's a bit dated. It's 1976. It's a waterfall process. They're using mainframes. But they measured their success by the number of defects that they identified. They reported that it was way cheaper to find bugs during inspection than during testing. I think in 1976, this made a lot of sense. Computers were expensive, they were slow, and there weren't very many of them. You had to stand in line, put your punch cards in a queue so they could be fed into the system to be compiled and tested. In 2018, cores are cheap. You can buy them on Amazon for cents. CPUs are fast. We can run unit tests, integration tests, style checkers, fuzzers, static analysis tools. I suspect that a lot of people in this room are actually writing those tools. Quite frankly, if you are relying on human code reviewers as your first line of defense against bugs, you're wasting money. Before reviewers start inspecting a change, run it through a battery of automated defect identification tools. This should be kind of obligatory at this point, but I think it doesn't happen as often as we would like. And this should be automated as part of your review submission process. At 2 Sigma, we do this. Our code review tooling will automatically build, test, and analyze each change before the reviewers start looking at it. So when someone sends me a change to look at, I know that it's already being tested and analyzed. If your change introduces new warnings, we add comments into the code review. We show those warnings. And maybe it's acceptable to have that warning. But the reviewers shouldn't be the ones responsible for finding that type mismatch or that potential null or something. We've got tools that are really good at this. Use them. We also look at unit test coverage. We show you if the changed lines are covered by unit tests or not. If your change isn't tested, maybe that's something you should be concerned about. So defect counts, though, are still how most code review papers report their outcomes. Why is this? Because it's measurable. Other things about code reviews are really hard to measure, but we can count how many defects people found. That doesn't mean that's the most important thing. Okay, so if it's not about finding defects, Are we doing it because someone higher up the management chain told us to? At 2 Sigma, I work in a regulated industry. So in a sense, my boss really did tell us to. We have a regulatory and ethical obligation to build and maintain controls and supervisory procedures for our trading systems. And we have decided that code reviews are one of those procedures and controls. Mandating code reviews by fiat isn't a bad thing. I'm not saying don't do that. In 2 Sigma's case, I think it's very responsible. But it's not sufficient, and in my experience, it can lead to friction and sometimes resentment. At a small company, code reviews might be optional. It might make sense. You're moving fast. You're not too worried about breaking things at this point. You've got a small group of engineers. They know the whole system. They built it. They all trust each other. If management tells developers that code reviews are mandatory, if they're not already widely used, and if the developers don't see another reason for doing them other than an order, they're going to bypass whatever technical systems you put in place. Not everyone, but some people are. Engineers are really good at finding technical workarounds to problems. But the more common thing you're going to see, I think, is rubber stamping. People are just going to treat code reviews as part of the process that they have to do because they were told to. So you send the code review to your friend at the next desk. He approves it. He sends you his code reviews. And you don't actually accomplish anything other than being able to put a check mark on a form that says, we do code reviews. If your only goal is to satisfy a requirement from management, you can't expect reviews to be productive. So, if I don't think you should be doing reviews to find defects, and if you can't just order developers to do better reviews, what other goals should we be thinking about? We really want engineers to be enthusiastic about code reviews. I want them to see evidence that code reviews are beneficial to them and to their team. There's a 2013 paper that I really like from Kelly and Bird. They surveyed and analyzed how code reviews are used at Microsoft. They interviewed developers and engineering managers to determine what their goals were, and then they looked at the code reviews that were actually being done, and they actually found some other goals that people hadn't identified that were actually happening. So, what were the goals at Microsoft that they found from interviewing the developers and managers? They found 6 goals that everyone thought was important. No big surprise. The first one everyone identified was finding defects. When they actually analyzed the code reviews, only 14% of comments were related to defects. So defects are being found in code reviews, but there's 86% of other things that are also happening. What are those other 86%? Code improvements. So these were comments that suggested changes related to readability, better commenting, consistency. Sometimes people found dead code that could be removed. It's not correctness. This is just making the code better. Alternative solutions. They found that developers would sometimes say, this is one way to do it, but there's a better way to solve this problem. This, again, makes the code better. It's not a defect, but it's a more efficient, more readable, safer, more idiomatic way to solve the problem. This one, I think this is one of the most important ones. Knowledge transfer. So this refers to dispersing knowledge about the code base. One of the developers they interviewed said, if you do a code review and didn't learn anything about the area, and you still don't know anything about the area, then that was not a good code review. Code reviews are a great way to see learn about parts of the code base that you haven't looked at before. On a large project, we're often focused on a narrow area. Code review helps you explore outside that area. It kind of gives you an excuse to go poking around. Team awareness. So this sounds kind of like knowledge transfer, but it's dynamic instead of static. Code reviews help other developers see what's changing in a code base. This is really useful because when something breaks next week, when I get some weird behavior, it's not a total mystery to me what's been going on. I've been following the changes through code reviews. Finally, shared code ownership. This is kind of a more abstract concept. Shared ownership is related to team awareness, but it has a stronger connotation towards active collaboration and overlapping coding activities. Both programmers and managers thought that this was a really good opportunity for to develop more people who could maintain pieces of the code. So they've got the knowledge, but they also feel like they understand it well enough that they could go in and change it, and it doesn't just belong to the author. It belongs to the whole team. And PowerPoint, there we go. So not all teams are going to have the same goals for code review, but I think they're going to be pretty similar. You might rank them a bit different or express them differently. It's really important to figure out what your team actually wants to achieve and to share that. How many of you have had conversations on your team about what your goals are for code review? It's pretty good. It's more than zero. There's 4 of you raised your hands, for those in the front. So start the conversation. Do a survey on your team. Ask people what they think they're achieving through code review or what they want to achieve. And then share the results. I think just enumerating the goals, if that's all you do, I think that's a really big step. And if your team's first goal is finding defects, which it probably will be, ask yourself if you're already using all the tools available to you. Are you using static analyzers and fuzzers, and are they as easy to use as they could be? Are they integrated right into your development process? Or is there one weird person whose hobby it is to run the fuzzer, who runs it every month or something and tells everyone else the result? Make it part of your process. Make it automated. Run it before the code reviews, not as an afterthought. Okay, we've talked about why we do code reviews. Let's talk about how we do code reviews. Code review is fundamentally a social activity. It's a collaborative effort. Small companies will grow into medium-sized companies. There's kind of a culture clash as we grow. As the company grows, things change, and we keep hiring more and more new engineers who need to understand how the undocumented systems that I wrote 5 years ago work. And as I said, at both of the companies where I worked, mandatory code reviews came with that growth. Code reviews are, in my experience, one of the main ways that developers interact with each other. At 2 Sigma, we have a lot of internal mobility, and we'll often ask engineers to act as reviewers on pieces of code that they're no longer responsible for, but which they wrote in the past. This is actually a really good way, especially for junior engineers, to interact with people across the company who they might otherwise not have much opportunity to talk to. When you're a new engineer, it's often hard to kind of get out and meet people and learn things outside of your team. Code reviews are an opportunity to do that. So ask, especially junior engineers, to be reviewers on code that might be relevant to them. Maybe not right now, but it will help them understand both the code at the company and your culture. It integrates them into your culture. So maybe code reviews are a clever bit of social engineering to trick engineers into interacting with each other. They think they're doing code reviews to find defects, but really they're meeting new people and learning things. I don't think that's really the intention. I think it's more of a happy coincidence. But it's a real consequence. So we could try tricking engineers like this, but I think a more productive approach is to consciously nurture shared goals of collaboration. I like to think about collaborative coding in a way that might be a little bit counterintuitive. I think coding is like writing. So we often think of writing as a solitary activity. The writer is cooped up alone with their typewriter in a remote cabin. But even then, a good writer is always thinking about their audience. When I'm coding, it's really tempting to think that my only audience is the compiler. The compiler and I are collaborating to generate the most efficient sequence of instructions. That's a really bad attitude. It's not really collaborative, and it doesn't result in good code. I really need to be writing for the people who are going to maintain, improve, and debug the code that I'm writing. Ideally, I'm the one who should be debugging my code, but in practice, that's often not how it works. So who I'm really talking about are my teammates, my code reviewers, and sometimes really just my future self. Me 6 months from now is sometimes really irritated by me today, who wrote really crappy code that I can't understand. If I think about writing code for this audience, I'm going to write better code that's clearer. So what does it mean to write code for humans? A lot of it is really simple things. Spell check your identifiers and your comments. Avoid using abbreviations that I have to spend extra mental energy to decode what you meant. Make it easy to understand. Use clear comments that are going to stand the test of time. Or even better, delete your comments and write code that is so clear that it doesn't need comments. Try not to surprise the reader. This is just the principle of least astonishment. Don't do clever things unless there's a really good reason to. It's always fun to be clever, but it often doesn't make your code easier to understand. And take advantage of the features of your language. Minimize the API surface, use private functions, use final classes. Don't leave me guessing how these things are meant to be used or where they're used. Use assertions. Just make it as easy as possible for the reader to reason about your code. Okay, how does the writing analogy apply to code reviews? Writing might be solitary, but good writers depend on a team of editors, proofreaders, or sometimes fact checkers to help them craft the perfect manuscript. In software development, it's a little bit different because these aren't specialized roles so much. We kind of take turns doing the different roles, but we're all editors for each other's code. Code reviewing is editing and proofreading. Reviewers proofread your work to make sure that it conforms to best practices and that it's sensibly organized. They might catch an embarrassing spelling mistake before your API goes into production and becomes impossible to change. They validate that your code is understandable. If your teammates can't figure out your logic today, what hope do they have a year from now when something fails in production and you're on a flight headed to Splash 19 in Athens? So when I'm lucky enough to have a professional editor edit something that I've written, I always learn something new about English. Recently, I've discovered that I don't properly distinguish between which and that. How many people know the difference between these? Half the room. So apparently this has to do with restrictive clauses, and it's a grammatical distinction that's largely disappeared outside of the United States. And I went to school outside of the US, so that's my excuse, I guess. But now that I know it, I'm trying to pay more attention to it and trying to write more precisely. The same thing happens with coding. A code review is a great chance to learn about a language or a library feature that you didn't know about or you'd forgotten about, or to share it, one that you did know, with someone else. And maybe if Phil, Helen Baker had better reviewers who'd been paying more attention, people wouldn't still be teasing him about a typo that he made in the HTTP specification in 1992. So I'm going to stretch the writing analogy a little bit further here. Every time you add a feature or a bug fix to your source code, you're creating a new piece of work, which is a patch. And to some extent, that needs to stand on its own. Who's going to read your patch? Well, your code reviewers are going to see it. And anyone looking at the change log is going to see it. You can think of the patch as the first derivative of coding. Back at IBM, I worked with a veteran programmer from the former Soviet Union who taught me to think about how my changes are seen by others in this way. I was looking at a particular piece of, a particular file that he had made huge changes to. He completely reorganized everything in it. And the functions in this C++ file seemed to be in a somewhat arbitrary order that didn't make sense to me. So I asked him why he'd chosen that order. And he explained that he'd kept the logic in the file in as close to the same places as he could. He'd moved all the entry points, renamed them, and changed it. A few of them were joined together, others were broken up into two functions. But if you diffed his version of the file with the old one, you would see that most of the logic was completely unchanged. He just changed how we invoke the logic. I'd never really thought about this before, but after Dimitri showed me this, I started paying more attention to how I structure my diffs so that not just the code makes sense, but the derivative of the code, the patch, also makes sense. So before you invite your colleagues to review a change, think about how to structure the change to make your intent clear. At 2 Sigma, we have some recommendations for code reviews, which really means patches in this case. They should be narrowly focused. Avoid mixing multiple changes into the same review. If possible, avoid changing code that belongs to 2 different groups. If you can change it independently, that's better. We use a mono-repo solution, so I can actually change like 200 code bases all in one review. That's generally a bad idea, but it's a cool capability. Make sure your reviews are well documented, and by this I mean explain why you're making the change. Your reviewers shouldn't come to the review blind. They should understand what your intent is. Are you fixing a bug, adding a new feature, cleaning up some technical debt? But if you find yourself adding comments to the review explaining how the code works, take a step back and ask if that's the right place for those comments. If the code itself isn't self-explanatory, then maybe that comment belongs in the code. And finally, like Dimitri taught me, code reviews should diff neatly. Think about how the diff works. Check it ahead of time before you submit the review. Before a developer clicks start on their code review, they should have looked at the change themselves, made sure that there are no unexpected changes, that there are no changes missing from it, and they should ask themselves if they're proud of that change. Can you tweak it a little bit better to make the code something you're proud of? So, like I said before, code reviews are a microcosm of your social culture. And sometimes people need to be reminded of this. One aspect of the social culture that we try to cultivate at 2 Sigma is kindness. Kindness is different than being nice. Kindness is rooted in caring rather than just being polite. It requires honesty because I want my teammates and my colleagues to be successful and to grow and improve. I might be nice to people I meet on the street, but I'm kind to my colleagues. So it means careful and honest code reviews and thoughtful comments. Remember, still with kindness, submitting your writing or your code to be criticized can be really stressful and anxiety-inducing. Recognize this when you're reviewing someone's code. They're kind of putting themselves out there and asking for criticism. So assume that they're acting in good faith and be constructive in your criticism, but also honest. Remember that 4 of the 6 code review goals that Kelly and Bird identified were directly related to sharing knowledge. That doesn't just happen by accident. You have to make an effort. If you're a reviewer, ask questions about the code. If you don't understand something, then either you've got something to learn or the code can be improved. If you're an author, try to anticipate questions ahead of time and include answers in the review before the review starts. Point out anything interesting and try to guide your readers through the change. Maybe even tell them where to start looking in the code review. Naturally, code reviews encourage us to focus on the little bit of the program that's changing. We just see the diff. Ask yourself about the big picture too, though. Take a step back. Ask if there's something missing from the code review. Should the change be applied somewhere else as well? Is there a common function that you know about that we should be using here instead of implementing something new? Is there a unit test that covers this new functionality? Look for what's missing. Use your knowledge of the whole product to be a better reviewer. And finally, many good reviewers use checklists to help them apply consistently high standards to code reviews. We know in aviation and medicine that checklists are really effective and they save lives in those fields. It's super simple technology. A mental checklist is good. A written checklist is even better. I keep moving the mouse around. So I said what we should encourage. There's some other behaviors we want to moderate or discourage a bit. We talked about rubber stamping before. This happens when developers don't see the value of code reviews and think it's just a process they have to satisfy. They just do superficial examinations. I think it's a symptom of that problem. The way to avoid rubber stamping is to get people to buy into code reviews and to share your goals of education, knowledge sharing, and also bug finding. The opposite of rubber stamping is nitpicking. These are people who don't do, their reviews aren't superficial. They go in and they find everything they don't like. There's more than one correct way of doing things. The way that I do it isn't necessarily the best way or the only way. There's a set of correct ways. And figuring out where to draw the line here can be difficult sometimes. Sometimes I feel something's really important and the author doesn't. Go talk to them. Maybe you can talk to them in person and work this out. This is a social collaborative thing. Sometimes you have to actually talk to people. Again, related to nitpicking is scope creep. Code reviews often get us looking at files we haven't looked at in a long time. Someone's changing 3 lines in one file. And your review tool gives you context and shows you the lines around it. It's not the author's responsibility to fix problems that are near to the problem that they're fixing. Just because you can see it doesn't mean they have to fix it. It's good to look at those things, but don't put that burden on the author. Open up a defect so someone else can come back and fix that other problem. If you train people that fixing problems creates more work for them, they're going to stop fixing problems. And that's perfectly reasonable. Gatekeeping. So we said that shared ownership is a good thing. It's good that people feel a sense of pride and ownership over their code. Where this can turn negative is when they're the only ones who are allowed to change it. Watch out if people are using code reviews as a tool to keep others away from their personal realm. We want shared ownership and collaboration. We don't want gatekeeping. Finally, back to kindness. Kindness also means respecting your colleagues' time. Respond promptly to code reviews. If you sit on a review for a week, you're holding up someone else's work, and you're forcing them to keep multiple things in their head at once. I want to get this code review done, integrated, so I can move on to my next task. Look, code review should be a positive experience. Developers shouldn't feel like they're being punished for improving source code. Don't let perfect be the enemy of good. You have to find this balance yourself. I can't tell you how to do that. I can tell you there is a balance. If developers don't, we want developers to be enthusiastic about doing code review because they want to learn, they want to help each other. In my experience, organizations often assume that engineers just instinctively know how to do code reviews. Maybe they think that universities are teaching code review. Has anyone actually learned code review at school? No, that's cool. Okay, some universities are doing code review. Or at least some professors are. Even if they are, like any skill, we can all improve with education and guidance. Without some coaching, code review can lead to conflicts because different participants are trying to achieve different goals. Going back to Michael Fagan in 1976, even then, he already recommended special training for code reviewers, and he also recommended checklists. I think at this point, the goals of education are self-evident. We want to make sure that everyone on our team shares the same goals for code review. We want to give people advice on how to make a good code review, how to be a good author, and also how to be a good reviewer. Oh, sorry, I animated this slide, I forgot about that. There we are. So code review education is an area where Two Sigma is still working at doing better, but it doesn't need to be time consuming. Write a 1 or 2 page document sharing your team's goals and expectations and socialize it. Put it on your internal wiki. Give it to every new employee. Write a short checklist for reviewers to use so that they can be more consistent. Again, really short. You probably only have to put 6 things on it. And at Two Sigma, every developer participates in a code review as part of their onboarding on their first day. This is a great opportunity to share with them why we value code reviews and what we expect from code reviews. Apparently I did more animation than I forgot about. So how can you get started? You don't need to start from scratch. I recommend the time-honored approach of copying from somebody else. I really like the guidance and the checklists from the Nerdery. This is a digital business consultancy firm. I have no connection to any of these companies, by the way. Their guidelines are on GitHub, and they've released them with an open source MIT license, so you don't even need to feel bad about copying them. Yelp has some really good guidelines. I particularly like that Yelp starts off by stating what their shared goals are. GitLab has good resources. They've made a particular point of defining clear roles in the code review process. I think this is a valuable way to think about it. We've got authors, we have reviewers, we have observers, and there's different kinds of code reviews. Take a look at their guidelines. You could just copy one of these. You can craft something specifically for your organization. And once you publish the guidelines, how can you reinforce good code reviews? here's one suggestion based on what we do at 2 Sigma. Make code reviews part of your performance evaluation. Code reviews are a record of an engineer's technical contributions as an author, but as a reviewer, it's also a record of their collaborative skills and how they've been helping the team grow. So we ask managers to provide examples of code reviews in level promotion packets. And then the review committee looks at the code reviews, and they've got evidence to see how this person is interacting, to see if they're really working at the level that they're trying to get to, which requires them to be building up other people, to be a mentor. We're also planning a code review workshop at 2 Sigma. So I told you that I'd like to think of coding as writing and code reviews as writing. So we were talking about how to do better code reviews, and a couple people have been to writing workshops where they bring in a sample of writing, and then everyone in the group critiques it and thinks about ways to improve it. We're curious if this can be applied to code reviews, so we're going to try it. We want to get a group of people together, and we're all going to look at each other's reviews and talk about how we can be better reviewers and what we can learn from that. More animation I forgot about. So finally, recapping. How can we establish a positive code review culture? We need to identify and communicate our shared goals, our motivations. Our engineers need a common understanding of why we do code reviews. We need to remember that code reviews are a collaborative exercise. We do want to encourage behaviors that promote teaching, learning, and shared responsibility. To achieve these goals, we need education. Doesn't need to be a lot, but at least write down your goals and share that. Have some guidelines. And if code reviews are your first line of defense against defects, you are wasting money. If your automated testing and analysis tools aren't at least as easy to use as your code review tool, invest in improving it. You'll end up with more maintainable code. Code reviews should have the engineers focusing on better solutions, more maintainable code, and teaching each other. Thank you very much for coming today. Questions? Use the mic.
Do you see a way to integrate code review or code review culture into the hiring process? So evaluating people's comfort levels or expertise with code reviews?
I haven't thought about that much, but I think it's a really interesting idea. So first of all, I'm going to say I think that as an industry, we're really bad at interviewing. We don't really know what we're doing or how to find candidates. I know Google did a study a while ago where they found that people's ratings on interviews had almost no correlation to their performance rating 1 or 2 years after they were hired, except that people who received low ratings on interviews tended to outperform. So I don't think we're very good at interviewing, but I have at times in interviews asked people to look at code and explain what it does and provide critique on it, which feels like maybe I was blindly moving towards what you're suggesting. I think it's a really interesting idea. It would be a way to get there, to get a feel for how they interact and what they look for. I wouldn't want to do it without sharing our code review guidelines first, because, like I said, this isn't something that people intuitively know how to do. That they need some training to understand what they should be looking for in a code review. worry is that they would just look for defects and think that it's a quiz. But I also think it's a fascinating idea, and I'm going to keep thinking about it and might steal it.
Hi, great talk. I was wondering if you had thoughts for open source communities, or if your advice would change at all between, a commercial entity and a broad open source collaborative project.
Another interesting question. I don't have a lot of experience working in the open source community. I have seen how Linus interacts with contributors, and I would recommend not following that model. So I think one of the great things that GitHub has done is the pull request model has made code review, it's just built right into GitHub. It's really widely known, and they've made a good UI for it. So I think that has made code review more accessible, and it means that engineers coming in, even if it's their first time working in a corporation, they're much more likely to have had some experience with code review ahead of time. I think that it makes sense for open source projects to have the same education element that I'm proposing, recommending. Just like they should have a code of conduct, they should say, and here's how we do code reviews of incoming code. This is how we expect people to behave in this environment. And perhaps it's even more important there because the community is a bit more nebulous than a company. People anyone can try to join the community, or can join and submit a code review, or try to become part of this. So, yeah, perhaps it's even more important there. But this isn't something I've thought a lot about. Thank you. Up front.
Thank you. I agree with pretty much everything that you said, so not too much stuff to comment, but two things. So concerning education and hiring and anything, I haven't tried it at hiring, but I'm from the industry, but I was asked to guest lecture for a course of software construction, and I incorporated code review in an exam. So I also taught them how to do this, but at the exam, one of the questions was, okay, here's a piece of C# code. What do you make of it? Tell me things about it.
Interesting.
So that's quite possible, and that went quite well. And later, students remembered that particular question and said, "Oh, that was cool."
What were you looking? What kind of things were you hoping they would see in the code?
Smells. Misapplication of patterns.
Okay.
I had one of the things that was wrong there. There were 3 random methods that were doing their own stuff, and the methods were called model, view, and controller. Yes, anything, but it's obviously an open-ended question, right? So it's and the second comment is that one thing that I disagree, maybe the only one, is the checklists. And people keep being fascinated with the success of checklists in medicine and piloting, and that's fair, but we as software engineers, we are in a yet better position. If you can make a checklist out of something, you can make a tool out of that, and you can automate pretty much anything that you can put in a checklist. So
I absolutely agree with that. You're right.
Maybe that's my bias as a tool developer. So I develop tools that I use myself.
So I'll rephrase it to say you should have a checklist, and in the ideal case, the checklist is actually just the tool. That be fair? The tool should guide you through the things that you would do as a checklist.
No, the tool runs on its own. You said it yourself that if you have automated tests, automated smell detectors, linters, and whatnot, they run on their own. And then
right.
after that, you review the code. But if you review the code with the thought of, okay, here are 3 things that I will look for, then why are you reviewing? Write the tool.
Right, and I think that a checklist could be, doesn't have to say these are the things I'm looking for. So we could have a checklist for when you're creating a review. Says like, have you described the purpose of the review? Have you reviewed it yourself? People often don't. I look at reviews like, what's this line doing? And the response is that wasn't supposed to be there. So, yeah, I admit I have to think more about exactly what should be on a checklist. And I'll admit that we don't have checklists at 2 Sigma. I would like to change that though, but I will think about what should be on it.
Could you comment on the personal drivers for people who are at the higher end of prioritizing time for doing code reviews? Like like for people that are who invest a lot of time in code reviews, why are they doing it?
As authors or reviewers?
As reviewers.
So I think there's a few reasons. I'm thinking about this. One is to educate themselves. So we have a tool that lets me sign up to say I want to be an observer on any code review that touches things in these directories. And that doesn't actually take a lot of time because I don't have an obligation in that case. I just get notified that there is a code review. So that's about keeping your finger on the pulse, seeing what's changing. It's keeping yourself educated. There's also I think it has to do with joint ownership as well. That I don't feel like I just own this component and everything else is someone else's problem. I feel a responsibility for the corporation's overall code base and quality. So I want to contribute back and help make everyone a better developer. So I don't remember where I saw this recently, but someone was talking about the role of a senior engineer. And it's not about producing more code or more important code than a junior engineer, because you can't write that much code. There's a limit to how much you can do. The real way to increase value, to be a multiplier, is to help other people write better code. So I think that part of the role of a senior engineer is to help mentor and educate more junior engineers so that they can be more productive. And code review, I think, is an important part of that. Does that answer towards your question?
Yeah, thank you.
So one of the issues we've always had with code review is that typically a review involves one person's changes. So it could be sort of a larger change or a smaller change, but a person feels sort of a personal ownership over the change.
Yeah.
And it's been difficult to sort of get people to see the code reviews as not as a personal critique, but as sort of a joint effort to improve the overall quality of the product. Can you sort of talk about ways that you guys have tried to sort of depersonalize code reviews and make people a little bit less sensitive to critique of their own work?
Yeah, egos are tough. I don't know if I have a good answer for that. I've certainly seen the same thing. And I don't think that it's isolated to code reviews. I think that code review is a microcosm of the organization's larger social culture. If people tend to work on a project by themselves that they have ownership on, I wonder if that's inevitable. If it didn't start as a collaborative project from the start, it's kind of hard to add collaboration, and that's a bigger problem than just code review. But yeah, I don't know the answer to that. I wish I could tell you there is a magic trick to get people to put aside their ego, but you have to be kind, but they also have to open themselves up to criticism, and that's tough. I don't know, is there anybody else who wants to try answering this one?
Yeah, so in my case, I moved from Korea to the States, and then it was really hard to get that criticism during the code review process. And then I had one-on-one with my manager, and we were talk about the shared goal and then the intention of the code reviewers. So I understand that with code review, I can improve my code, and then it will be more safer in the production. And also, I know why they review the code and then give me that some critics or that kind of comment. So it doesn't mean to attack me, but help me to produce more better code. So that helped me.
I think, like I said, part of it is people have to assume good faith. If your reviewers are being assholes, yeah, people are going to take it personally, and I don't blame them. So it's not just on the author. The reviewers have to have some tact as well, and part of that starts with actually talking about these things and saying these are the behaviors that we expect in code reviews, and this is what we value as an organization. But yeah, the societies are hard.
I was just going to add that in my personal experience, usually when code review comes up as a criticism, it's usually a big reflection on your senior leadership in your engineering department. And similar comments coming from different senior people will come up very differently, even though they have the same message. And this is usually more a symptom of looking at how your code reviewers are acting more than actually having to break the egos of more junior developers.
Oh, yeah, absolutely, yeah.
And the common mistake is actually to say, well, no, senior leadership actually knows what they're doing. You will just follow as is. And
Yeah, you're right, and I apologize for focusing on ego at the first point, because yeah, that's probably not that can be an issue, but it's not probably not the most common problem.
although, if I may ask in the same vein, how will you try to reconcile that? The fact that, well, you will face two different part of your organization, usually the more junior ended, which may have a harder time understanding what's the true purpose of code review, and your senior leadership, which may not understand the boundaries where code reviews are. How do you try to meddle that and try to get a communication where you basically blur the boundaries in between, say, well, it's just one team, it's not really a game in between the juniors and the seniors?
Yeah, no, it certainly shouldn't be I don't want to see conflict between the junior and senior engineers. I think it's for junior engineers, it's a learning opportunity, but for senior engineers, it's also a mentoring opportunity, and that's also a skill that not how do we reconcile between management and the different engineers? A lot of it is simply talking about it. So we often, in my experience, code review comes in, it's like, we're going to do code reviews, here's a tool, here's how you use the tool. Nobody talks about why we're using the tool. So having the written down, this manifesto, what goals you're trying to accomplish, I think really helps. Because then you don't have this conflict where people think they think that you should just be looking for bugs, and you think that you should be improving the code, and I don't know, someone else thinks something else. If we have these shared goals, I think there should be less conflict.
Well, as conflict comes up, so I mean, obviously in coding, there's many ways of doing the same thing.
Yep.
And conflict comes up. Has anyone here or you experienced a conflict that has escalated, and how do you deal with it? Because you know, sometimes these technical conversations are, you know, there's not one answer. So.
Yep. So I have experienced that. And you have to evaluate what the conflict's about and whether it's worth the fight. Sometimes we're disagreeing about how to format something. That's just not that important. As far as I'm concerned, with all the wars over the correct indentation style, the only important thing is that you have some sort of standard so people stop arguing about the damn thing. But then there are things that actually matter, where there's safety at stake, where the code might not be wrong, but is at, like this gentleman said, there's a bad smell that puts it at so high risk. And you have to make a judgment call, and sometimes that does mean escalating, and at least in a company, there is some management hierarchy, and if you have to, you can go up and you can argue with this and have someone higher up make a decision. In open source, that's harder because you have to rely on consensus. Or Linus, I guess. But yeah, there's no good answer for that. I would say pick your fights. Yeah. I think it's lunchtime.